Hello, I'm very glad to start with day 35 and this is the first hour. Let's get it started.
Two examples, like I said, and then we'll move on to our next section. Is it possible to add just a whole number to a fraction like that? What do you think? Why not? Put a 1 there, that's right, great. So we can change a whole number to a fraction itself by putting a 1 underneath it, all right? So I can't just do this, right? I can't just go, oh, this is x plus 2 over x plus 5. Can I do that? That'd be easy, that'd be nice, right, if we could do that. What the 2 really means is, yeah, that's 2 over 1. So now we can go back and do the same process. Can you find a common denominator with this? What is our LCD here? That's nice, right? When the other one's a 1, the LCD is apparent. It's just the other denominator. So our LCD is, the 1 doesn't really count. We don't include the 2, that's a numerator. We do x plus 5. Which fraction or fractions do I need to multiply? The left, the right, or both? Good, yeah. The right already has our LCD. That's actually how we got it. So we don't need to multiply the right fraction by anything. The left fraction, we will. And we know we're going to multiply it by whatever it takes to make the LCD come up in that fraction. So if I have a 1 here, I'm missing the entire x plus 5. And of course, we'll extend our line. We'll put some parentheses where we need them. Do I have an LCD now? Yeah, x plus 5 and x plus 5. We get to now make one fraction out of this. So because I have my LCD, I can write one fraction. What is my LCD again? So that goes here. And on my numerator, I'm going to write my first numerator just with the 2 first, plus my second numerator. So first numerator plus second numerator, it's all over the x plus 5 that I already had on the denominator. What do I do now? Do I simplify now or do I distribute now? Yeah, I can't cross anything out yet. I need to distribute first. 2x plus 10 plus x over x plus 5. Our last step in this case is just combine like terms because it's not going to factor. We're going to get 3x plus 10 x plus 5. And that's as good as we can do. How many people feel okay with what we've talked about so far today? Would you like to try one of these on your own? Okay, we'll do one like that one. And then I'll write up a few more. Actually, you know what? Maybe we'll do one more together, and then I'll give you a couple to do on your own. That way you have some more time for that. There we go. Okay, we're going to do this completely together on this one. We're going to step by step through this, but I want you to tell me the steps, and we'll work on it together. What's the first thing that I might want to do if I'm trying to subtract these two rational expressions? What's the first thing you do every time you get a rational expression? Well, yeah, but before you do that, every time you factor. Every single time. Yeah, you guys are right. You're going to factor every single time. At least the denominators. So let's go ahead. I want you to factor right now. We're not talking about the numerators. Those will stay the same. We're talking about the denominators. factor. Let's start with the easy fraction, the one on the right. Ladies and gentlemen, what factors out of the denominator on the right-hand side?
4.
4. Okay, very good. So we're going to get 4 times what, folks?
3.
Perfect. Did you get that? Sweet. How about the left one? Do I need a diamond problem for that?
No.
It doesn't even have 3 terms. It's certainly not a difference of squares. It has 2 terms, not a difference of squares. It has a plus in the middle. It's not a sum of cubes or anything like that. It's not that hard, actually. If you're thinking those ideas, like, oh, we're forgetting one thing. We're forgetting about the GCF. Remember the greatest common factor that we're supposed to look for every single time? What is our greatest common factor here? So don't forget about x. We can factor that. The x is in common to both. We get 3x plus 2. Did you make it that far? What's the next thing we get after you factor? You tell me.
LCD.
Let's go ahead and find our LCD for me. Okay, so write LCD right up top. Look at our denominators. We're going to take the largest power of each different factor. So write that down right now if you haven't already. This should not be the hard part. The factoring is actually, in the next step is kind of a hard part. This is nice and easy part. LCD just lists out all the factors. Tell me one factor I'm going to have. Okay. You also have 3x plus 2, right? Do I need it squared or not? No, it's in different fractions. It's fine. I just need it once. What else? 4. Anything else? So what I'm going to write is 4x like that. I've got the x. Check. I've got the 3x plus 2. Yep. I've got the 4. Yes. I have 3x plus 2. I've already got that. So that is my LCD. Did you find that on your own? Good. Okay. Now we use that to make some equivalent rational expressions. That's our next step. So basically, we're just multiplying by whatever we don't have in the LCD. So I'm going to enter if we haven't done that already. Okay, what gets multiplied on the left fraction, ladies and gentlemen?
4.
Oh, that's not too bad, right? Just a little 4. You do that. How about the white? On the right, we have this fraction. What gets multiplied over here? I'm going to start saying right. Did you find this also?
Yeah.
Good. So now that we have what's missing, we can see this. We're going to have our 4x and we have our 3x plus 2. That's the same. We have 4 and our x and our 3x plus 2. Let's go ahead and let's multiply these fractions. We're going to get 16 over 4x, 3x plus 2, minus, what do we get on this fraction?
3x squared.
Oh, good. Don't forget about x squared. And we get 4x. I'm just writing this in the appropriate order for us. 3x plus 2. And you can see that we've done it right because we have our LCD in both spots and it's the same as the one we had up top. That's great. That's exactly what we want. Now what do?
One fraction.
Great. One fraction. We've already got this set up, right? We have the same denominators. That's fantastic. 16 minus 3x squared is just the first numerator minus the next numerator. 4x, 3x plus 2. What are you going to try to do now? What would you try to do at this point? Try to factor. Now, Even though it's a minus, even though that's a square, that number is not a square. This is not a difference of squares. You can't factor this one. All right, so you're done. You can't factor that. You can't simplify anything. You're done as far as you can go. You okay with that? Kind of nice, right? Stop. Okay, now I'll give you 2 to try on your own. So that is on that one, and I'll write one more up on the board in just a second. So work on those 2. If you're feeling brave and you finish those 2 and you want to try another one, we are going to do this one in just a second. But I'll write one over here. If you finish those 2 for sure, then if you feel brave, try this one. If you're feeling good about this stuff. If you're not, well, try it anyway. Remember. Here. That last one's a good one for us. That's something you can expect on like a test. Okay, that last one right there. So we'll get to that one. So we're factoring if we have to. We're definitely finding the LCD. We're using that to make equivalent rational expressions that's purposely unsimplifying. Put them together. We're making one fraction out of it, distributing if we have to, combine like terms, and then we start simplifying. Yeah, see, lots of good work so far. That's great. By the way, is there any more homework to turn in? take about another minute. Try to wrap up the problem that you're on. Hopefully you've done the first one, you're working on the second one at least. If you're done with the second one, I do want you to try the third one. Okay, so in every example, we're going to try to factor first. If we don't have to, that's great. If we do have to, we do that. But in either case, we look at the LCD and right after that. So on our first example, well, hopefully, you saw this and said, well, I need to make that a fraction. Did you do that? Good. Then we go ahead and because one, you can't factor in b plus 3. So our LCD in our case, not too bad. It's just the b plus 3. That's the only denominator we have. Therefore, it has to be the LCD. Did you find that as well? Now, next, we go and multiply. This fraction is great. It already has the LCD. With this fraction, we're going to multiply b plus 3 over b plus 3. Did you get that far as well? We extend our line. We put some parentheses like we know how to do. That's not a problem. We notice that, in fact, we do have a common denominator already. That's what we wanted, b plus 3. This is really just b plus 3 because the 1 doesn't do anything. And that's the same as what we wanted. So we'll make one fraction out of this. Our denominator is the LCD, b plus 3. On the numerator, we're going to have b plus 3 times 3. I'm just going to write the 3 first because that's easier to see that we need to distribute. That's the only reason. And then the plus b, that's our second numerator. After that, we certainly can't simplify, we're going to distribute. We'll combine some like terms. We'll try to factor, but none of this can factor. And so you're done. How many got that far? That's great. That's fantastic. Good for you. Okay, next one. Where we couldn't factor the second one, the first one, we can't factor this one. So we'll look at those denominators and try to factor. factor. It's very similar to the one I had on the board here just a little while ago. So we'll factor that. The numerators we leave alone. What factors out of our denominator here? So we factor that out, and we get, hopefully, 2x. Very good. Minus the 3x will stay the same. What factors out of this denominator? And we get, very good. How do you make that far, Lucia? Good, very good. Now, we get to find our LCD. Again, the LCD is just a listing out of the different factors. So when I look at this problem, honestly, the first thing I look for is not the big ones, I look for the small ones. I look for the numbers first, I look for any numbers I have. So here are my denominators, I'm seeing, first off, the 2. I'll write the 2 first. Then I look for any x's or y's or variables hanging out all by themselves. So I've got the 2, then I'm going to write the x. And lastly, I'm going to write any big factors that I see. I see the 2x plus 3. If I see it twice, they're a different fraction, so I only need it one time to cover both of them. Are you with me on that? And then I double check. All right, do I have the x up there? Yeah, I do. Do I have the 2x plus 3? Okay, I got that. Do I have the 2? Yeah. Do I have the 2x plus 3? Yeah, I already covered that. So that's my LCD. Did you make that far? Awesome. Now we need to multiply it by what's missing. On the left side, I notice I have an x and the 2x plus 3, but I'm missing the 2. On the right-hand side, I've got the 2, I've got the 2x plus 3, I'm missing the x. Now we multiply it, we get our 10 over 2x, 2x plus 3. Never distribute that denominator. 3x squared like we had last time, and 2x. 2x plus 3 over there as well. We notice LCD occurs in all 3 spots. That's exactly what we want. We can make one fraction out of this thing. We'll get 10 minus 3x squared over our LCD. We would try to factor, but you can't factor that thing, so you're done. How have you made it that far? Good, that's fantastic. Did you try the third one? It's kind of fun, right? Lots of good factoring stuff. We like factoring. You better, right? Because you're doing a lot of it. You don't, well. Of course, the first thing we do is we factor the denominators. We have to. Now, one of these things, actually, both of them are stuff we've seen before. One's a diamond problem with no extra step. Why does Doesn't it have the extra step on it? Great, those are kind of nice, right? Those are quick. Down from 4 and 4, 2 and 2. We just do x plus 2, x plus 2. Did you get that as well? Another one is different squares, which should just be bam in your head at this point. We got x squared minus 4, with x plus 2, x minus 2. Did you do those? Yeah. So here again, we got 4 and 4. The numbers that work there are 2 and 2. X plus 2. X plus 2. Here we have the difference of squares, and we know how to factor that already as x minus 2, x plus 2. So the factoring shouldn't hold us up anymore. That should be an easy part of it. It's not too bad. Next, we get to find the LCD. Our LCD is going to be every different factor that we have up there and a large power that occurs. But I mentioned one thing to you, and this is why we're doing this example. Before you calculate, before you find the LCD, you have to make the denominators as concise as possible. Right? You have to make them as good as possible. So the problem here is that if you just do this, you don't quite have the LCD yet. And the reason why is because, can you write this differently? How would you write it? That's going to make a difference in your LCD because that's a larger power. So here we'll do that. This one, we can't put that together, so we leave it. But notice how this is going to change our LCD right here. That right there, that power 2. So now we go through and look for different factors, and here's how you do it. You say, what are the different factors that I see? Name a different factor that I see. X minus 2. Okay, I get X minus 2. What other different factors do you see up there? And you can take the largest power that you find of X plus 2. So while I have X plus 2 in both spots, what's the largest power? So you have to put the 2 there. Okay, that's a must. We practice this when we're applying LCD, but you have to remember to do that in these step problems. And now we're going to double check just to make sure we got that. Do we have an X plus 2 squared? Yeah. Do we have an X minus 2? Do we have an X plus 2? Yeah, we have at least that much. It's right there. Are you with me on this LCD in this case? Okay. We're still going to multiply by the appropriate things now. Let's try to figure this out together. On the left-hand side, this one's going to be the easier of the two sides to really see. Can you tell me what's missing that I need to multiply by, please? Great. On the right-hand side, am I missing anything? Good, I'm missing X plus 2 because I want squared. I only have one of them. So it's already got the X minus 2. I just need one more X plus 2. Well, we know what to do. We're going to extend our line. Extend our line, put some parentheses. I'm going to do an extra step here just so you can see the concise form of this to make sure that we actually do have LCD. I am going to write this part first, my 6x. I like that first because we're going to be distributing that in a second. My x, I'm going to keep that in front. So we're going to have 6x, x minus 2, all over x minus 2, x plus 2 squared. Ladies and gentlemen, should I simplify this? No, I'm purposely unsimplifying to keep my common denominator. Plus x times x plus 2 over, this is x minus 2, and look at, that's x plus 2 squared. And right there we can see that I do have my common denominator. That's what we wanted. So we'll continue up here. We're going to write this as one fraction before we distribute. Now, I know some of you are thinking, why do we actually do that? In this example, it's not so crucial because we have a plus sign. But you notice that if that would be a minus sign, that minus sign would distribute to both terms, all right? And if you distribute now, some of you are probably going to forget that. I can't have you forget that. So we wait until we get one fraction before we distribute and combine like terms. That's the idea. Now we get to distribute. So can you tell me what we're going to have if I distribute this thing on the numerator? What am I going to get? Beautiful, all right. And then? Perfect, keep going. Okay, not so bad, not so painful, right? Just distribute. Denominator stays exactly the same. In fact, once you find your LCD, you really don't change it until the very last step. You simplify some stuff. Next step. Okay. I see my x squared, so it's giving me 7x squared. I see this gives me minus 10x. Now, the next thing you might try to do is at least think through the factoring, okay? Now, if you look at the numerator, you see you can factor out the x. Do you see what I'm talking about? You can do that, but you're going to get 7x minus 10, which is not going to simplify, so it's up to you whether you want to factor it or leave it in this case. Okay, you just check it, make sure that if you did factor it, it wouldn't simplify, then you can leave it. If you factor it and it can simplify, then of course you do that. Would you like to try one on your own? Okay, let's do one on your own. And we'll go step by step. Well, I'll have you do each step and we'll see how it goes. We move kind of quickly through it. Me asking that question is kind of like the nurse asking, so do you want a tetanus shot? Because you know it's good for you, but you really don't want it. It's painful. Yeah, the nurse actually asked me that, like the other day I was at the doctor's like, do you want a tetanus shot? I was like, no. She goes, well, you're going to get one anyway. So I snuck out before she could give it to me. I did. That's horrible. Okay, now, we should be very familiar with these problems. First thing I need you to do is do the very first step, which is to do what, folks? Factor. Go for it. Oh my God. That room over here. So factoring, these should be kind of apparent to us at this point. This is a difference of squares, x minus 3, x plus 3. Did you get that?
Yes.
Fantastic. The other one is 7 on the top, 12 on the bottom. They done a problem, no extra step.
Yes.
So we should be getting
4 x plus 3.
both positive?
Yes.
Okay. Now at this point, there's no grouping to make squares. That's okay. What we want to find out is what is the LCD. So go ahead and do that at this point right now. What was that?
X minus 3.
Perfect. Before I do that, because that minus sign, that is going to distribute. My LCD doesn't change. I'm going to distribute, combine like terms, and then we're going to be done. So distributing, hopefully you've done this already. You have the 2x squared minus, good, and then we're going to have minus 3x squared minus 12x. Did you make it that far? Especially the minus 12x, you have that. Good. The last step we're going to have to do here is combine some like terms and then write a fraction over again. So if we combine like terms, how many x squareds am I left with? Negative x squared. And? What? Okay. If you have plus 6x, that sign's wrong. If you have minus 6x, you've done your math wrong. You should have negative or minus 18x on your figure right there. That's about as good as we can do. We can try to factor that out. If you tried to factor, you factor negative x, you'd get x plus 18, but that's not going to simplify. So how many people made it that far, or at least feel good about that? Good, good, good. Well, so last time I did give you that problem to think of, and hopefully on your homework you realized how to use the LCD to make your common denominators, add or subtract them, do all that fun stuff, and it's not too bad. Now, what we talked about the very last 2 minutes of class last time was that problem, and I wanted to refresh your memory on how to do that. I had you think about that for a little bit at least. I said, do you remember the difference between something like this and something that was on your homework? What is here that was not on your homework? Yeah, that makes a big difference in how we go about doing this problem. If there's no equal sign, all we can do is manipulate those expressions. We can't really get rid of denominators. If we have an equal sign, though, you need to be paying attention. When you have an equal sign, though, what you can do, from our very first day of class, basically, you can get rid of those denominators. Do you remember how to do that? Do you remember that we could do that, first of all? Do you remember that, the first day? That we could get rid of denominators? I hope you do. What's the first thing we would need to do in order to get rid of denominators? Hey, you know what? That's the same thing we did in your homework, right? And pretty much everything you're going to do has to do with LCD somehow, unless you're multiplying or dividing them, because then we don't even care about it. We just cross things out. That's what we do. So with this type of problem, the first thing we need to do, just like anything else, just like on your homework, we're going to find the LCD. So on our steps, which we're going to write down right now, hopefully you're waking up. Some of you guys look tired today. Man, you got to wake this up today. This is a good lesson. I practiced this one over the weekend, like in the mirror and stuff. No, I'm just kidding. But you need to have this one down. What's really important is that you see the difference between this section and last section. I cannot have you do the same thing. Do the same thing on this section, the last section, you're going to mess yourselves up so bad you're never going to finish the problem. All right, you have to see the difference here. So first big difference, these have equal signs. That's why we're going to do it completely different. One thing is similar is step number 1, you must find the LCD. And in order to find the LCD, you might have to factor first. We learned that on your homework, right? You have to factor those denominators in order to find that. So you might have to factor those first. Let's go ahead and do this with this example. Now, this is kind of an easier one because, well, we have these numbers, but let's practice that. What is the LCD in this case? Is it 20 from these two or 20 when you consider all three of them? What should I do? Okay, so we're still looking at every fraction you have, and we're going to take LCD is 20. And I'm going to rewrite this problem down here because I'm going to show you what to do. I need to have a little bit more space though. Here's where the differences happen. This is what you need to see in this section. Last time, what you would do in the last section, if there was no equal sign, is right now, pay attention on the board real quick, what you'd be doing is you'd multiply this by 5 over 5, this by 4 over 4. Are you with me on that? And you get 20. That happens if you don't have an equal sign, because you don't have two sides of anything, right? You just have expressions that are added or subtracted. When we have two sides, the process changes. We're going to use the fact that we have two sides of an equation and the fact that I can multiply each side, or in other words, every term. Those words should be ringing a bell for you in the first day class, first week class. That if I have two sides and multiply every term by the same number, it's still equal. So instead of doing the 4 over 4, the 5 over 5, we're going to make this a little bit easier. We're going to go ahead and eliminate the denominators in one step by taking the LCD and multiplying every term by the LCD. This is what we did the first day of class, is we got rid of fractions this way. So what I mean by that, hopefully this looks familiar to you. We say, okay, what's our LCD? Oh, we have 20. What we're going to do with that 20? We're going to multiply both sides. When you multiply both sides of an equation, we get that the equation is still a true statement. So we'll say, I'm going to multiply both sides. If you remember both sides, that meant every term. If you don't remember that, go back and watch that video. We've already done this particular problem already. So we're going to say, okay, I multiply this by 20. Do I mean 20 or 20 over 20? Which one in this case? Just 20. I don't need 20 over 20. That's going to make your fractions huge. You don't want to make huge fractions, do you? You want to get rid of fractions. That's what we're trying to do here. Don't multiply by a number over something if you have an equation. So we have 20, we have 20, and we have 20. Not 20 over 20. What is it? 20 over what? 1. Yeah, you can put 20 over 1 if you want to. So we found the LCD. We might have to factor that first here. We don't have to. We're going to multiply both sides. That means every fraction by the LCD. Multiply every term by the LCD. And the reason why this works is because you're multiplying both sides. I'm going to make a little note here. When you have equations, you're never multiplying LCD over LCD. You never do that. That doesn't work for us for equations. We're trying to get rid of fractions. We're not trying to make them bigger. Okay, this is not like addition subtraction where you had to do that. If you have equations, you have two sides. We're using that fact to get rid of fractions for us. How many people feel okay with what we just talked about so far? That's good. Now let's see why this works. So we found LCD. We multiplied every term by the LCD. That's right here. Hey, we don't have to multiply. Does that simplify? What simplifies here? That's why we have the 1 down there, right? Because we don't need that 1 to simplify with anything. It's not, we're not going to make it 20. We don't need that. The 4 changes into a 1. The 20 changes into a 5. And what's this?
5.
Here we have 5 goes into 5 one time, 5 goes into 24 times, so we have plus 16. On the right-hand side, what happens there?
1.
Can you notice something? This is the easiest one to notice this on. I'm going to change it slightly. Don't change your problem, just watch. If I put 20 over 20, if I did that, that's going to be 20 over 400. Do you want 20 over 400? Probably not. That's not going to be very fun. You don't want to do that, right? You want something easier, not something harder. So we multiply every term, because we have two sides of this thing, by the LCD. We simplify what we can, and now we have a very easy equation after that. Isn't that nice? Isn't that nice? Something from fractions into something without fractions by one step. All you have to do is find the LCD. Don't do the LCD over the LCD, but multiply every term by that and cross stuff out. It's going to work. You will get rid of fractions. Now, after this is a very easy problem. Well, for you guys it is. Subtract 16, we get 5x equals negative 15. We divide by that 5. We get negative 3. We check our work. You can plug that in and check your work. That's going to work out, and we're done. So a couple things. Of course, we still have to find the LCD. Of course, we multiply every term. You can't skip a fraction on this case. You can't do this, in other words. You can't just multiply these two and forget about this one. Or multiply this one and forget about one of these. It's got to be every term in there. You have to do that. We'll also just multiply the LCD, not LCD over anything besides 1. It's not LCD over LCD. Or it's not 4, 4, 5 over 5. We're not doing that sort of thing here. We're trying to get rid of fractions. Meant to eliminate denominators. Now let's try this with a couple more. We're going to build ourselves up to ones that look really hard, all right? They're not going to be very hard because you can get rid of denominators and makes things really easy. But they're going to look really hard. So we're going to build up to that to see how, that we can really do this in any case. By the way, when I'm writing these problems down, I'll often leave a little bit of space in between the sign and the fraction because I know I'm going to have to multiply by something. Is that clear for you? That way you don't have to have it all scramped, like crunched in. Oh, you know what? I made a mistake already. Change that to a 5, please. Okay, let's do this problem together. Now, one thing that I'm going to show you before we do even the very first step here is you might want to make things just like in the last homework. Make things into fractions first. Right here, you see we have one term that's not exactly a fraction yet. Make that into a fraction. That way you don't confuse yourself with your LCD. If you're in this, that number wouldn't really matter for us, but the point is, let's make this into a fraction first. And how to make a number into a fraction? Just do that real quick. That way you don't let that 15 get confused in your LCD, all right? Because if that number was like, I don't know, 30 or something, and you try to find the LCD and you consider that, that's going to make it a much larger LCD than what you need. Are you with me on this? So make your fractions first. Now let's go ahead and find our LCD. Let's look at those numbers. Our denominators are 3, 5, and 1. What's our LCD? It is 15. In this case, it is that number. I just didn't want you to think that that 15 had anything to do with the LCD in this case, because it doesn't. It's just there. It just happens to be the number. So we're going to take it and write that LCD 15. What do we do with that LCD, ladies and gentlemen? Okay. So that means definitely over on the right-hand side, I gotta multiply that by 15. Hey, tell me something. Are those 15s going to simplify that? Some yeses and some nos. What do you think? Is it like this? No. It's actually like that. Do you see the difference? So I gave you this problem. Don't automatically think that you can cross it out. It has to be set up correctly for you. Is that the only thing we need to multiply by 15? No. How many other things? So 15. Let's make sure this is 1, 2. All three of our fractions are multiplied by 15, and we need 15 over 1. That's fine. One more thing. There's something I'm missing right now in these problems that we talked about. What are we missing? Yeah, we're missing the parentheses. We're missing those parentheses. We talked about this. Every time you have a numerator, at least a numerator, with more than one term, you need parentheses because ultimately we're going to be distributing here, right? So you have to add the parentheses. So we're going to do this. Ooh, another important question. This one you should know because we already talked about this. But should I be distributing here or should I be simplifying here? I had two people say two different things. What are we trying to do? Are we trying to make our numerators larger or trying to eliminate our denominators? Okay. If you distribute, you're going to make your numerator larger and still not get rid of your denominator. Are you with me on that? If you do that, look what you do. You have 15x plus 30, it'd still be over 3, right? And you can get rid of that 3. You're going to factor it back out to exactly what you have right here and then simplify. So if you distribute now, you're wasting 2 steps. You're wasting distribution and you're wasting refactoring. Get exactly the same thing you have right there. But this is why I have you think of this in class, right? That way when you get home, you're not like, what do I do now? So we don't want to distribute. Remember, you're trying to get rid of denominators. That's what you're trying to do. So do it as soon as you can. That's right here. So don't distribute now. Do you see that we can eliminate the denominators now? Yeah. This really is 15 over 1. This is 15 over 1. That's 15 over 1. We have the same situation we had over here. It has to work this way because we're using our LCD. That LCD combined the factors of our denominators, so they must go into it. What goes into both 15 and 3? What goes into both 15 and 3? Oh. Has to work, right? 3 has to go into itself. 3 has to go into 15 because that's how we got 15. So we're going to cross out the 3 and put a what? We're going to cross out the 15 and put a what? And the 5. 5 goes into 5 one time and it goes into 15 3 times. Again, do these 15 simplify? No, we can't do anything with that. So we're going to continue. We're not going to distribute right now. We're going to just rewrite the problem, just like you did with addition subtraction. We don't distribute because they can't have you miss negatives or things like that. So we're going to say, okay, we've got this 5 here, and we have the x plus 2. By the way, nod your head if you're okay on getting the 15 and using it appropriately, just like that. Are you okay on why we're not distributing right now? Why we're not distributing up here? We want to simplify that first. That's the main goal. What's the next thing I'm going to write? Minus. Okay, great. We can't forget about that. And then that's 3, and then there's x minus 1. On the right-hand side of our equation, how much do we get? Good. Do you notice what's going to happen here and why I can't have you distribute until this step? If we distribute up here with that 3, some people are going to forget about that minus, right? They're going to give me minus 3x minus 3. When in fact what we're going to get is minus 3x. Everybody's going to get that part. Everybody always gets that part right. It's this one, the second one, that's important because that's going to change the value of your final answer. So that negative, that's going to contribute. We get our 5x plus 10, no problem there. That's the easy one. Minus 3x, but if we're not, we're going to get plus 3. And that's kind of a big deal. You get minus 3 there, that changes everything. Okay, hey, we've seen things like this. This is a whole lot better than that one, right? No fractions, we just have something simple. This is like pre-algebra stuff. This is pre-algebra level right here. It's combined like terms of solving basic equations. What do you do? Or did I just skip it away? Skip it away. So we combine some like terms, we get our 2x plus 13. Subtract that 13. We're on the home stretch now. What is that, 112 or 212? Sorry. Last step is always to divide, so when we divide, looks like we're going to get 106. Would you ready to kind of feel okay on doing a problem like this? Good, I'm going to give you one to try on your own. It's similar, just make sure you can go through this process, okay? I want you to try it once before we go any further. So go ahead and do that one. I need you to do everything that we just talked about. So there's no factor involved here on the denominators because they're just, but find your LCD, use that, use parentheses where you need to figure out what that's going to be. Almost done with that first one. Hopefully you found the LCD. Hopefully you multiply that appropriately. Definitely need some parentheses on that problem. Distribute correctly and then solve the basic equation. So first thing, what did you find for the LCD in our problem up here? Are we trying to find common denominators or eliminate denominators altogether? Which one? Try to eliminate. That's good. Ladies and gentlemen, when you get to your test, you're obviously not going to have me telling you what to do on this problem, right? I'm going to say, oh, you need to eliminate your denominators. You're just going to have to know. What tells you up here, everyone should know this, what tells you up here that you can eliminate denominators rather than just find a common denominator? Good, that's very good. So if you have the equal sign, you know you can eliminate. Are you with me on that? If you don't, can you eliminate them?
No.
Just find common ones. That's the difference. Okay, so we have our LCD. We're going to be able to eliminate denominators, but in order to do that, you have to multiply every term by the LCD. That's both sides, every term. Not LCD over anything besides one, because we're trying to get rid of things, not make it worse. We definitely have to have some parentheses. I hope you put that. And now we get to do the fun part, which is simplify some stuff. We don't want to distribute now. We want to get rid of things. So the 12s, oh, you know what? That is 12s are gone. The 4 and a 12, well, that simplifies to a 3 over 1, because the 4 goes in the 4 one time and a 12 3 times. 3 and 12, that's going to give you that 4. How many people made it that far? Good, fantastic. We continue. I'm not going to see it yet. I'm going to write it just to make sure I see. Continue, we're going to combine some like terms. If I combine, yep, we're going to be positive 23 at that. How much? So you can divide by -1 here, or just switch both signs, that's fine. Yep, we're going to be positive 23 at that. Make x over 1, you can put that. Okay. You have an x squared up there. Subtract 2x. But you have to feel okay with that. Good, good deal. Maybe I'll give you one of these to try and just look at. Right now, I want to go into a couple other ones. We'll do about 2 more. We'll do 2 together. I'll give you a couple doing your own. Okay. Do you need one like that to try on your own, or do you feel good about this? You want one of those? I'll give you one later then. Okay. See, it's getting better. Getting better. Now, they look more nastier. Whatever. They look more nastier, but they're not going to be any different from what we just did. Not any different from what we just did. All you have to remember is that we're finding LCD and using the LCD to simplify.
أمي أنا خايفة شديدة يا أمي.
Light denominators, that's what you're doing. In order to find the LCD on this problem, though, you have to do something. First, what is that thing? First. And that means we're going to factor that. So right now on your own, I'm doing that side. That's exactly what I'd be doing right here. Do you see what I'm talking about? That's exactly what you'd be doing. You have x plus 5 or x plus 5, you have a common denominator, you combine. That's what you would do. As soon as I have an equals and sum of the fraction, that changes the plan. That says, oh, equal sign, now I can get rid of denominators. That's the goal now. That means we're going to do this process on that problem. We're going to take the LCD and multiply every term by the LCD. So it might get a little long here. Let's do the first one. Remember that this is still all over 1, if you want it to be like that, and you're still multiplying. And this is all over 1, and you're still multiplying. And so is that one, and you're still multiplying. Let's get going on this. So again, this mean on either. So here you got a problem, right? So you plug that in. Is 26 fifths minus 3 going to give you 0? No. The only thing that would give you 0 would be at 3 here, right? The only thing that would give you here you got a problem. There's only one thing you need to check.
It's 2x.
Okay, I need to make sure that you see this. Watch up on the board here. There is one thing you need to check. You need to make sure that you can plug this number in and that it's legal to do that. Here's what I mean. Notice we have fractions here, right? What's the one number you cannot have on the bottom of a fraction? So if you were to plug this in and it made 0 here, or 0 here, or 0 here, you'd have a problem, right? So you plug that in. Is 26 fifths minus 3 going to get to 0? No. The only thing that would give you 0 would be at 3 here, right? Here would be a negative 5. Remember talking about the domain stuff? So you check that. Just make sure that this number is not going to give you 0, and you're okay. That's a solution. If it gives you 0, then you cross it out. It's not a solution. We've understood that problem. Good. All right. Okay, like I said, we're going to do one more together. I will give you 2 to 3 to do on your own, and then we're done. Honestly, we already had this section kind of covered from the first day of class. I mean, it's the same stuff. It's just now you're working with expressions like those. So we're going to do that and then give you some practice. Okay, last one we're doing together. I want you to walk me through the. Tell me what I need to do first. Tell me what I quickly. Let's go. Wherever one. Great. That's a great idea. We can do that. What's the next thing I need to do? Okay. LCD might be. I mean, you have to factor here. We don't have to, so we don't. Okay, times cross some stuff out. Plus 3x. That's combining like terms. Next step is, well, either A or B. Choice A is you get everything to one side. And And 0 on the other side. Choice B is you solve this just like it is because you don't have an x squared. Choice B. So we're going to do what? Perfect. We get 2. Very good. And the last step is? And we get x equals 1. How would we feel good about that solution? How would 2? How would 2? Except, I want you to look back. We just talked about this. Is that a solution? It looks like it, right? We solved it. We got an answer. Look back at the original problem. Take that 1, plug it in, look at the denominator. Okay? Here, hey, that looks good. It's 5. Here, that looks fine. That's fine. That's fine. Here, that's fine. Here, oh, crap. That's not good. What happened? We plugged in 1, we got a 0, right? On the bottom of our fraction. Why does that happen? The answer is, when you take this and you multiply by the LCD, you're essentially moving this of your fractions. You see what I'm talking about? Essentially, that's what you're doing. In doing that, you can create some false solutions. This is a false solution. So what you do, you get all the way down to here. That one worked just fine. That was fine. It didn't make 0. This one, this is the problem, because when I plug this into the denominator, it gives me 0. That's undefined. If you get something that's undefined, all you gotta do is solve it down. You're not gonna do it to the very end. Just cross it out. There is no solution to this problem. I know you're not used to this. The problem is not having solutions, but this is one of them. Okay, I'm going to give you a couple. Give you. Two problems to do on your own. One similar to this one similar to the one we did over here. Okay, so there you go. Work on that one. I think I'm going to write 2 on the board. I think we can go pretty quickly through this.
من خايف شديد يا أمي، خايف شديد يا أمي، خايف خوف شديد. أمي أنا خايفة خوف شديد. يا عمير خايف شديد، يا عمير خايفة 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 شديد. So it's been 49, 49, minus 1, time, plus 49. 7 times y 35 minus 35 14.
Yeah, just wrote that down wrong. Yeah, we gotta get started on the first one, we're not gonna have time on that. So on the first
Is x plus 3, 3 and 2, 6, 3 and 2, 12, 2, 6.
problem. Of course, we're gonna make this all over one. I hope that you did that. I hope you found your LCD. LCD is is what here? We're going to take and multiply everything by x. Really, x over 1. We can show that if we want. Here we'll get 8x. We'll get, oh, those are gone. We'll get plus 7. We'll get x squared. And we'll get plus 2x. How many people made it that far? Now, do we solve this like it is, or do we have to get everything to one side and 0 on the other side? Gotta get 0. Otherwise, the factor's not going to make a difference. So 0, we're going to move the left to the right or the right to the left? So minus 8x 7 equals x squared minus 6x. We'll subtract 7. 0 equals x squared minus 6x minus 7. You still with me on this, folks? We'll do what now? I'm thinking minus 7 plus 1. You're not quite done yet. You do have to set them each equal to 0. X minus 7 equals 0. X plus 1 equals 0. We'll add 7 to 7. We'll subtract 1. X is negative 1. You have to check one thing. Make sure these denominators don't make this 0. They don't, because they're a positive and negative number. They're integers. So we're good. They're both solutions in this case. Now, the next ones, we don't have time to go over. I only have like 10 seconds. Do you know how to do this one? What would you do first? Great. Factor, find your LCD, multiply 3 things by that, simplify, distribute, and solve it. You don't even get x squared on this problem. This one, can you see your LCD already? Just multiply everything by x plus 3. Distribute. You will have an x squared. Get everything to one side and solve it. What I'm going to, these are our last 2 problems. We'll do them the first maybe 5 minutes of class next time. And then I'll post that with this lesson. But we're essentially done. That's it. That's all we got to cover. So I'm going to give you your homework. It's not going to be due tomorrow, but I really do need you to start on it because we're probably going to have another homework assignment tomorrow, okay? So you need to be almost done with this problem this time. So here you go. So if you remember from last time we were about to do these problems, can you tell me what's the first step in doing the problem on the left-hand side, which we need to know? So let's factor that. These 2, of course, are factored, but this one we'll take and factor as 6x. And we'll get x plus 2, x minus 7. So we should know how to factor the diamond method, no big deal. After you factor, what's the next thing we should try to do, folks? Okay, can you see the LCD up there right now? What is the LCD for us? X minus 7. Even over here. Some of you have the wrong numerators, and I've crossed it out because you're not. Distributing negative. And the reason why we can do this is, again, what do we have up here that we didn't have on the last section's homework? That's why. That's what tells you you can do it. If you have an equal sign, that means you can multiply both sides by the same thing, or in other words, every single term. We can simplify out our denominators, and that lets us do this problem very easily. So what simplifies up here? How about our first fraction? What are we going to have left? That's great. So all of this stuff is gone. It's 6x. Then we have a minus sign, and what simplifies over here? Now, are we going to distribute now? Now or wait for the next step? What do you think? Yeah, we're going to definitely wait because we want to make sure this minus sign gets distributed with that 3. That's an important step. I'm still seeing that on some of your homework that you're not distributing negative. So When you get this homework back, some of you have the wrong numerators, and I've crossed it out because you're not distributing the negative, and you're adding together like terms that really shouldn't even be there. Notice that the reason why we can do this is, again, what do we have up here that we didn't have on the last section's homework? That's why. That's what tells you you can do it. If you have an equal sign, that means you can multiply both sides by the same thing, or in other words, every single term. We can simplify out our denominators, and that lets us do this problem very easily. So let's simplify this up here. How in our first fraction, what are we going to have left? That's great. So all of this stuff is gone. It's 6x. Now we have a minus sign because we get everything to one side. So we're going to divide by 2. And unless we made a mistake somewhere, that should be our answer. How many will feel good about doing a problem like that one? No, Roy, you guys okay with that? Yeah? Okay. How about left row? Are you guys okay with that? Yes, no? Yeah, okay. So the whole idea is factor, find your LCD, use that if you have an equation to simplify your denominators. After this, I went through this really quick because this is old stuff. This is really, really old stuff. So this from here should be like a no-brainer. thing I've taught you in this class is how to do factoring, LCD, and then using that to get down to this stuff. This is really this class right here. This stuff is all algebra stuff. Okay, now the next one. We're going to go ahead and look at this. Before I even think about the LCD, what should I do? Okay, so maybe make these things into fractions, so you're not considering this and this as your denominator. So fractions, anything simplified. So what am I going to have? Okay, that's the left side, and add an equal sign. So, right side? Okay, now, here's where you need to know what to do. Either you know what to do or you're going to get stuck on this problem. Do we get everything to one side or do we solve it directly? What do you think? Why is that different than this? That's right. That's exactly right. So here I'm going to keep x squared positive. I'm going to move this stuff over to the left-hand side. So minus 4x. Then, let's do that. We can't do this, we can't factor yet because we don't have the 0. We need a 0 over there for the 0 product property to work. So that's why we have to keep going and get x squared minus x minus 12 equals 0. That 0, that's really important. We've talked about that a few times in here. You have to have the 0. Okay, we have the step equals 0, and now what do we do? Yeah, the data method says we're gonna factor that thing. And here, at this point, we should be really good at factoring these problems. There's no extra step. It's pretty basic. We're going to get x minus 4 and x plus 3. So far, so good? Are we done? Now what? Okay. One last little step. We add 4, we get x equals 4. We subtract 3, we get x equals negative 3. And we're done. How many feel okay with solving these things? Good, very good. Now, we get to move on to chapter 7.6, or lesson 7.6. And in this section, we're going to talk about how to solve some problems. I'm going to give you a couple techniques. We'll be able to deal with several different problems. I know problem solving is probably not your favorite thing in the world to do. Yeah. Oh, good. Yeah, we forgot to check that. Yes, you do need to check your answers. So the 4 works. You caught the negative 3. Does everyone see what she's talking about? Yeah, I said last time I broke my own little rule. Good catch. I was just testing you. You passed. Yeah, the 4 is just fine because we plug that in and it's 7 and 7, but she's actually right. The negative 3, if I put that in there, I get 0 on the denominator. That's not a good thing. So you do have to cross that one out. Yeah, we only get one solution there. Good call, thank you. Okay, anything else that we've got up there?
Words are flowing out like endless.
Favorite thing in the world to do, but I'm going to teach you some techniques that make it kind of approachable at least. So we'll talk about 7.6, some problem solving, and this is going to involve some proportions as well. If you remember what a proportion is from your pre-algebra days, a proportion is simply an equality of two fractions. So, for instance, are these fractions equal? Yeah. That's a proportion. It's just one fraction equal to another. The nice thing about proportions is that you probably learned something about these. If you cross multiply, you ever heard cross multiplication? Cross multiply, it's equal. The cross products of a proportion are equal. So for instance, if I cross multiply here and here, I see that 1 times 8, notice how I'm multiplying across, will equal, in fact, 2 times 4. Now, while that might not be so surprising to you, do you see that it's equal? 8 equals 8. This allows us to solve proportions really, really easily. For instance, let's say I didn't have 1/2 equals 4/8. I had something like 3/8 equals 9 over x. Hey, is that still a proportion?
Yeah.
Is it a fraction equal to a fraction?
Yeah.
That's what a proportion means. So is that still a proportion? Sure. Is cross multiplication still going to work? Absolutely. If cross multiplication works in every proportion, it also has to work in this proportion as well. So what that means is that if you ever get a proportion, it's not really a long process to solve this thing. All you have to do is find the cross product. Cross product means multiplication. Just cross multiply. So if we cross multiply, can you tell me what two things I'm multiplying together first? Okay, so I need to cross here times here. Equals, what's it going to equal? Where are you getting 72? So just like up here, we could multiply the 1 times the 8, and that had equal to 2 times the 4. We can do that in this proportion also. We can multiply the 3 times the x. It has to equal the 8 times the 9. This happens with every proportion that you see. Are you guys okay with this? If you're all right with getting this form. Yeah, this is from a long time ago. Just kind of refresh your memory, and then we're going to build on this in just a bit. So yeah, we get 3x equals 72. Last step we have to do is just divide. It's a basic equation for us. X equals, how much is that going to make? And you know what? You can check your answer. If you plug in 24 right there and you simplify it, you're going to get out 3/8. So that's one way to check that. Now, how many feel all right with this, what we just did? Good. Now, we can apply this to some rational expressions. And it's going to be kind of nice. I'm going to leave this one on the board for just a second, because I want to compare this. Hey, do you have an equal sign? You know what that means? That means that you could, look at the board here real quick, you could do this problem exactly the same way that you did this problem, which would be find 35, multiply both sides by 35, and cancel out the 5 and the 7. Do you see what I'm talking about? Then you distribute. However, is this a proportion? It's one fraction equal to another. Do you see what I'm talking about? That's what makes this a proportion, one fraction equal to another. Is this a proportion? Do you see how we have more than one fraction over here on the left-hand side, and more than one fraction over here on the right-hand side? A proportion is one fraction equal to one fraction. So as soon as you have this other garbage kind of messing it up, this x out front, and it's 2 out back, once you start having that, you can't cross multiply because, I mean, when you think about it, what are you going to cross multiply? Just these two? and then you're missing out on that one and that one. See what I'm saying? So this is kind of a special case of rational equations. It says if you have a proportion, cross multiply, it makes things a little bit easier. If you forget about cross multiplication, you just blank it. You go, oh my gosh, I don't know what to do with proportions. Well, you can still solve it that way, right? It just takes you a little bit longer. It's not a problem. You just have to find the LCD and do the same exact thing. But if you have a proportion and you want to do like a shortcut, I guess, use the fact that this is a proportion, all you need to do is cross multiply that. Great song. Great song. Girls just want to have fun, right? Were you born in the 80s? You weren't born in the 80s? 90s? 70s? Just kidding. I didn't ask, I just suggested. Okay, so firstly, do you see the difference between this problem and that problem? Do you see how this is not a proportion, yet this one is a proportion? Are you sure? Proportion just means one fraction equal to another one. This is really similar to this problem. If we cross multiply, we can solve this pretty quickly. So let's do that. If we cross multiply, I am going to get what times what here? 2x plus 1 times what?
5.
Now I'm going to put the 5 up front, because that is going to distribute. You see what I'm talking about? I can't just put 5 times 2, because we have to also take that 2 to 1. Equals, same thing happens here, 7 times x minus 3. So we have those parentheses signifying that we are going to have to distribute that. But now, look, I mean, we didn't have to find LCD, did we? You could have done it that way. You could have found 35, multiplied both sides by 35, simplified it, and then distributed just like you did here. You could have done the same thing. But this makes it a little quicker because you don't even have to think about LCD. None of you are with me on that. It's kind of nice, right? Does this work here? You can't cross multiply because you're forgetting about these things. But here, no problem. We'll distribute 10x plus 5 equals 7x minus 21. Okay, let's see if you recognize these things. Should I get everything to one side and 0 on the other side, or should I go directly from here? How? Okay, those are small variables, so we're going to get rid of that. (3x plus 5 equals negative 21). From here, basic equation, get rid of the constant term first. We'll subtract 5. We get 3x equals negative 26 after we divide by 3. X equals negative 26 over 3. Do you feel okay about that problem? So let's try one on your own. Let's do that. There you go. I want you to identify if it's a proportion or not. See that you can see that in your head if it's a proportion or not. So be thinking about that, and then solve it. Is that a proportion? Good. You see that there's one fraction equal to one fraction. You see what I'm talking about, right? One fraction equal one fraction. That means that you have two options to solve this, too. You can either find the LCD. LCD in this case would be 18. You with me? And you can multiply both sides by 18 and cross stuff out and then distribute. That's fine. Or you can cut out the part of finding the LCD. And that says if you have a proportion, it's a special case of equations. You can, what's that called? Cross multiply, or you might also hear it said cross product. Find the cross product. Cross product just means cross multiply. How many people cross multiplied? Good. Did you use parentheses when you cross multiply? All right. So here we said it says 9 times x minus 1. It really doesn't matter which one of these is on which side. It does not matter. So if you have this one first, that's fine. It's an equation. The sides really don't matter. Okay, you can have it on either side. And then 2 times 3x plus 2. Did you make it that far? Cool. Then we distribute. We all know how to distribute. That's not a problem. We're not going to get everything on one side. We're just going to subtract a smaller variable in this case. We'll get rid of our constant term. Last step is always to divide without a coefficient. We're going to get 13 over 3. Would you raise your hand if you got 13 over 3? Fantastic. If you didn't, see where your mistake came. Where I can't have it come from right now is right here when you're cross multiplying. You have to have this set up correctly. That's like the foundation of what we're learning. Everything else is just basic algebra that people accomplish in this class. Now, how can we use the idea of proportion in a couple scenarios? The first one is with a word problem. You guys ready for a word problem?
No.
Yeah. Okay, well, if you don't want, do you want to have a party instead? You should have a party?
Yeah.
Cool, we're going to have a math party. Are you ready? Yeah? Okay, math party, here we go. So you're having your math party. Awesome. And you're going to go to the store and you're going to buy sodas. So you went to the store already and you bought 4 2-liter bottles of soda. And what it cost you was $5.16. But because it's a math party, it's super cool. And so more people want to come. So you have to go back to the store and buy more soda because you know 4 is not going to be enough. Because you have like at least 8 friends coming. It's big for a math party, trust me. So you have these 4 2-liter sodas and it costs you $5.16. How much will 7 more cost you? How much will 7 sodas cost? Now, I gotta tell you, there's several ways to do this problem. Lots of ways. I'm gonna show you one way. I'm gonna show you the proportion way because that's what we just covered, okay? So here's one option you have for solving this problem, and setting up a proportion. Here's what you need to know about proportions. As long as you keep the units grouped together by fraction, then you're going to have your proportions set up correctly. Okay? You either group units by fraction, like one fraction is the same type of units, and another fraction is the same type of units, or numerators and denominators. Things have to match up. So numerators have to match up. same thing, and fractions have to match up. You're talking about the same units. Here's what I mean by that, because that was pretty vague. The units we have in this problem are what?
Contraband.
Ja, middag. أمي. Como fiambre. Prima devo fare con invece So that's it for today.